Now let's do more examples. Examples 1 to 4 are very simple and basic. For example, in all the examples we just covered, the arrival rate is the same for all the time periods we were simulating, and the capacity is pretty much fixed. So, but oftentimes in real world, we often see time-varying capacity and arrival rate. So how do we model that? For example, if you talk about restaurants, the arrival rate for a particular restaurant can vary at different time of the day. So we have peak time, we have off-peak time. So how do you model that? So this is something we're going to cover in example 5. So example 5, we're talking about DMV office. So if you read the problem, you can see the DMV office opens at 8 o'clock and it closes at 5 p.m. And the arrival rate to this particular unit is different at different time periods. And also because arrival rate is different, the number of people on duty is also different. So you can see the table lists the number of people on duty for different time periods. So how do we model that? So let's create another example, example 5, and save it as example 5. The second thing we are going to see is a new module, the decide module. So we have seen create, process, dispose module. So now we're going to see a new module, decide module. So we use decide module to separate the flow units into multiple branches. So here, customers who walk to the DMV office may seek different service. Some people want to renew their driver license. Other people may want to renew their vehicle registration. So people are looking for different service. So how do we separate the flow? So we can use the decide module. So first of all, we add a create module. We'll always need a create to generate customer arrival process. Then we use add a decide module. This one will separate customers. So we generate all the customer here, then we separate them into two flows. So first flow are the ones who's looking for driver license service. So we add a process module, then we add dispose module. Then we have a second flow, which is for vehicle registration. So how do we do that? So before we add another process module, we want to select this one. Okay, so make sure you select this one, highlight this one. Look at all these dots surrounding the module. Means this one is selected. So once we click it, we can add a process module. So now you can see these two are connected. Okay, otherwise, you have to manually connect these two modules. So you can see when customer arrive, some people go here, go to the right-hand side. Some people will go down. So these people are looking for driver license service. These people are looking for vehicle registration service. Then we also, of course, we need the dispose module as well. So that is the model. Then we move to step 3. We have to, first of all, define the time-varying arrival rate. We also need to define a time-varying capacity. How do you define it? When you have time-varying capacity, when you have time-varying arrival rate, we can use a schedule. So schedule, look at here. This is a data module. So click schedule. So right now, if you click schedule, you don't see anything. It's blank because we haven't defined anything yet. Now we have to define it. So how do you add a new schedule? So here it says double click here to add a new row. So double click. You can see a brand new row. Then we need to edit. So how do we edit? So then so after you double click, then you right click. So right click, you choose edit by dialog. That brings up a dialog box. The given name is called arrival rate. This is a customer arrival rate. It's time varying. So what is type? So using schedule, there are two options you can choose. You can either do arrival rate or can do capacity. So of course, this is arrival rate. So arrival rate, it's a type is arrival. Then this blank box, we had to define it. Click Add. If you go back, look at table. The table says there are 4 different time periods. The first time period is from 8 a.m. to 11 a.m. The arrival rate is 95. So you type 95. So 95 is arrival rate. This arrival rate will last for how long? From 8 a.m. to 11 a.m. That's 3 hours. That's why we type 3 on the duration. So we have arrival rate 95 from 8 to 11, which is 3 hours. Click OK. Then you add a second period. Second period, you can see the arrival rate is 125. It goes from 11 a.m. to 1 p.m. That's 2 hours. You have to do this in sequence. You don't skip anything. Then you click the next period. The next period is 100. That's the arrival rate. It lasts from 1 p.m. to 3 p.m. It's 3 hours. The last one is 130. The duration is from 3 to 4:30. It's 1.5 an hour. That's 1.5. Some people will stop here. It looks like it's 4 different time periods. But remember, this DMV office opens from 8 a.m. and closes at 5. So really, we need to list all the arrival rate from beginning to end. So here, the last period is from 3 to 4:30. We're still missing 1 period, which is from 4:30 to 5. From 4:30 to 5, the door is closed. They do not let people in, but they will serve everybody who's already inside the office. So the last period is a hidden period. The last period arrival rate is basically 0. It will last for another half an hour, so 0.5. So this is something a lot of people will be missing. Okay, 0 and 0.5 last for half an hour. Be careful. So that is a first schedule. Next, let's define the capacity. So again, it's double click, add a new row, and right click, choose edit by dialog. So we have 2 kinds of capacities. One is a driver license capacity. The other one is a vehicle registration capacity. So let's do driver license capacity first. So it's called DL capacity. So what is type? Type is capacity, of course. So vehicle for driver license capacity, there are 4 different time periods. The first period, the capacity is 10. It goes from 8 to 11 a.m. so it's 3 hours. The second time period is 13 capacity. It goes from 11 to 1, it's 2 hours. The next one is 10. It goes from 1 to 3, so it's 2 hours. The last one is 15. It goes from 3 to 5, so it's 2 hours as well. So do we need to add a hidden one? For capacity, because it shows the capacity from 8 to 5, and there's no hidden period. So 4 periods are enough. That's pretty much it. So this is a driver license capacity. Click OK. Then we want to add the vehicle registration capacity in a similar way. So first of all, double click, add a new row, and right click, edit by dialog. The VR capacity. Type is capacity. The first period, capacity 8, lasts for 3 hours. The second period, capacity is 12, lasts for 4 hours. The last one, capacity is 15. It lasts for 2 hours. Then click OK. That's how we define a time-varying arrival rate and time-varying capacity, so under schedule. Now let's go back and look at the flow chart. So first of all, let's double-click Create One module. This one defines customer arrival process. Given name is called customers arrive. Again, this is informational. Entity type, customer. So time between arrivals. Here, I have different options. In this case, because we're using time varying arrival rate, so we're going to use a schedule. We pick schedule, then we pick a arrival rate. Okay, arrival rate is a schedule we just defined. So choose schedule first, then pick arrival rate. Click OK. So now we're done with the create schedule. Then we'll move to decide module. Double click. Give a name. This is informational. DL or VR. Type, there are different types you can do. Here, because I only have two possible customers, so I'll use two-way. And how do we separate them? It's by chance, randomly, right? So if you read the question, it says about 60% people looking for driver license service, the rest looking for vehicle registration. So if you look at these two lines, the line goes to the right. This represents the ones who's looking for driver license service. So I type the percentage 60%. The remaining 40% will go down. Okay, this number represents the percentage people who will go to the right, and the remaining, which is 40% in this case, will go down. These people will look for vehicle registration service. We move to the next module. Process 1, double click. Give a name, it's called DL service. Logic action, cease delay release. We add a resource. Resource basically talking about agent. The ones who's handling driver license service, a DL agent. Driver license agent. Quantity to 1. We only need 1 people to serve us. Distribution is a triangular in minutes. The minimum, it takes 5 minutes, most likely 10 minutes, maximum 15 minutes. So this is also given by the question. So for driver license service, the time it takes follow triangular distribution. Minimum 5 minutes, maximum 15 minutes, most likely 10 minutes. Make sure the units is minutes. Okay, don't do hours. So click OK. Similarly, we can do process 2. This is called VR service. Cease delay release. VR agent. Quantity 1. So what's the distribution? The distribution is also triangular. In minutes, time is in minutes. Minimum 10 minutes, most likely 15 minutes, maximum 20 minutes. So click OK. Then dispose module. Very simple. We simply change the name. DL customer sleeve. The second one, VR customer sleeve. Okay, almost there? Almost there. Now we need to change the capacity. So how do we change the capacity? We go to resource. I have defined 2 different kinds of resource, DL agent and VR agent. Currently, they both are using fixed capacity. The capacity is 1, which is not right. Okay, so let's look at DL agent first. It's not fixed capacity, time varying. Because it's time varying, we choose based on schedule. Then you select which schedule. We have DL capacity. This is schedule we already defined, DL capacity. Similarly for VR agent, it's based on schedule as well. Which is schedule? VR capacity. So that's how we change the capacity for both type of service. So now we are done with building the model. We can run a simulation. But before we run simulation, we need to change run setup. So give a name on the project parameter, give a name. It's called DMV project. This is informational. Type your name. Replication parameters. We're going to run for 9 hours. 9 hours. It's only run for 1 day. Base time units, which is minutes. Click OK. Make sure to save it. This is example 5. Now you can run a simulation. If you want to run faster, you can slide the bar. Now you can see the average wait time is 11 minutes, 11.5 minutes. And total time the customer spending DMV is 23 minutes, which is not bad. And then you can also look at the resource utilization. So driver license and the vehicle registration agent, it's about 93% for both, about 93%, which is, full, I would say it's fully utilized. So this is a simulation model for DMV. In this example, we basically learned 2 things. One is how to model time varying capacity and time varying arrival rate. Second one is how to use the Decide module. So let's close it and end a simulation, save it, close it. Now let's work on example 6. In example 6, we're going to model something new. It's called lost customers. So we say waiting is not good. Waiting makes customer unhappy. In the real world, because of long waiting, business will lose customers. Not every customer is willing to wait. If the line is too long, people may go to your competitor. If the waiting time is too long, you're losing customers. So how do we model such behavior? We'll show this in example 6. So open the brand new file, save it as example 6. So in the example 6, we're going to simulate a fast food restaurant, Chipotle, for example, during peak hour from 11 to 2 p.m. for 3 hours. So within a 3-hour period, we want to see how many customers they might lose if waiting line is too long. So how to do this? So first of all, add a create a module. We say we always need to create a module. Then we add a decide module. Customer arrive here. So why do we need to decide a module? This one models customer behavior. Customer will check the line, check the waiting line to see how many people are waiting. If the waiting is too long, they will leave. If not too many people are waiting, they will join the line. So whether or not they will be joining the line depends on the length of the waiting line. So that's why we need to decide a module to model customer choice. And after this, to the right, that means people are willing to join the line. So we have a process. The first process models order and pay. So if you go to Chipotle, you have to order your food first and then pay for it. So afterwards, you have to wait for your food to be prepared. So here I have a second process module. The first process module models the process of ordering food and paying. And second process module models preparing food. After that, you will be leaving. Customer will be leaving. On the other hand, if customers choose not to join the line, they will leave right away. So click decide module, add a dispose module. So there are 2 possibilities. So that's how it works. If people are willing to wait, they go to this process. If they're not willing to wait, they will go down and leave the system. So this is example 6, a fast food restaurant. Now let's edit the information. So first of all, create a module. Give a name, it's called customers arrive. Entity customer. Arrival process. If you read the question, it says it's random. And in the arrival time follow exponential distribution with average in the arrival time 1 minute. So it's 1 minute, it's not 1 hour. So it's exponential, that's the default. One default, that's 1 minute. So average-wise, every 1 minute, you will see one customer arrive. So 1 minute. So this is the arrival process. I will leave this alone. Decide module, because that's the most difficult one. I want to do process one module first. We'll come back later. So for process, this one models order and pay. Customer order and pay. Logic action, cease delay release. And resource-wise, when you order and pay, you deal with a cashier. You deal with the cashier. So resources cashier. And delay type. If you read question, it says it's a uniform distribution. It's anywhere between how long it takes to take order and pay. It takes anywhere between 1 to 2 minutes. 1 to 2 minutes. So it's uniform distribution, 1 and 2 minutes. So that is order and pay. Second one, process about preparing food. Preparing food, give a name, it's called prepare food. Logic action, cease delay release. Resource, preparing food, it's handled by different people. It's handled by cook, not a cashier. So it's cook. Delay type, it's a follow triangular distribution. It's anywhere, the minimum 2 minutes, most likely 4 minutes, maximum 7 minutes. So to prepare the food, it's done by cook. Follow triangular distribution, minimum 2 minutes, most likely 4 minutes, and maximum 7 minutes. So make sure you choose the right units. Now let's do decide a module. We already used the decide module in example 5. Example 5 is pretty simple, two-way by chance. So how do we separate the flow? It's random. We randomly separate the flow. But in this case, restaurant example, we try to model customer behavior. Customer choose to join the line or leave by certain criteria. It's not based on chance. Okay? It's not by chance. It's by certain criteria. What's the criteria? The criteria says if the waiting line has less than 15 people, the customer will join the line. Otherwise, they will leave. So that's the criteria. Depends on how many people are in the waiting line. If it's fewer than 15, they join the line. Otherwise, they will leave. So it's not two-way by chance. It's two-way by condition. So we have to specify condition. So two-way by condition. So what is the condition? What is the condition that people will join the line? The condition is when the waiting line has less than 15 people. The given name is called wait or not. Wait or not. Wait or not. Two-way by condition. Then we have to specify the condition. So if we choose expression, so under if we choose expression, then we have to write down the expression. Basically, we have to tell Arena the condition is when the waiting line is less than 15 people. So right click on the value, right click, choose build expression. And what's the expression? The expression is queue length. The queue length is less than 15. So we look at queue. Look at queue. We look at current number in queue. Click current number in queue. We want to see current number of people in the queue. So which queue? I have two different queues. The queue we are looking at is the order and pay queue. The first queue, the order and pay. So that is queue length. When this queue length, we choose less than equal to 15 people. So that's a condition. When the queue length is less than 15 people, click OK. So that's a condition. Click OK. So now we have specified the condition. Next, we want to change the name for to dispose modules. This is for informational. So leave with purchase. So this means people, they purchase food then leave. This one means leave without purchase. So this represents lost customer. So we're almost ready to run simulation. But before we run simulation, there's one more information we need to change. So in this example, currently the restaurant hired 1 cashier and 4 cooks. So we need to change that capacity for different resource. So how do you change the capacity for the resource? So we have to click a resource. So you can see right now we have 2 kinds of resource. One is cashier. Capacity is 1, that's fine. Second one is cook. The current capacity is 1, which is not right. We are supposed to have 4 cooks in this simulation model. So change it to 4. Now we are finished with the model. We need to change the run parameter. Go to run setup, give a name. It's called restaurant project. Restaurant analysis. Your name. Replication. Order run for 3 hours. Run for 3 hours. Base time units, we use minutes. We'll run for 3 hours only. So now we can run a simulation. Now you can see, with 1 cashier and 2 cooks, the average wait time is about 12 minutes. Average wait time is about 12 minutes. Is that good or bad? Well, it's probably not the best. So let's close the report. I can zoom in and pay attention to this little number next to the exit, next to the dispose module here. You can see the little number is 40. So from here you can see within a period of 3 hours, 40 people left without a purchase. That means during this 3-hour period, we lost 40 customers. So according, each restaurant can be different. For example, let's assume if we lose $5 profit from each customer, if you lose 40 customers, that basically means you're losing $200 in a 3-hour period. So this is something can help us make decisions. So currently we have 1 cashier, 4 cooks. We're going to lose 40 customers within a 3-hour period. Next question is, what if we hire 1 additional cashiers to see is that going to help the situation? So we start from here. We're going to change the capacity. So go to resource, cook will still be 4. We hire 1 additional cashier to see what will happen. Of course, by hiring 1 additional resource, we can make things better. So if you only have 1 cashier, so you're going to lose 40 customers. But what if we have 2? How many customers you will be losing? So change it to 2, save it, and run simulation. You can see report. First of all, the wait time will change. The average wait time was 12 minutes. Now it's about 4.5 minutes. It's better for sure. So 4.5 minutes average wait time. So how many people are we losing? We go back, you can see the number here shows 0. So we're not going to lose any customer. So we'll get all the customers served, which is good. So by doing simulation, we can calculate, we can capture this kind of information, which is very important for us to make decisions.